Firewalls, one of the most essential security tools in cybersecurity. But where did they come from? How did they evolve? And are they still as effective in today's ever-changing digital landscape? Today we're exploring the history and evolution of firewalls, from their early days as simple packet filters to the sophisticated security systems we rely on now. To guide us through this journey, we have exclusive insights from some of the pioneers in firewall technology, Steve Bellovin and Marcus Ranum. The year is 1969.
Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
In ARPANET, the first inception of the modern internet had just been created. Networking was an academic and military experiment, a marvel of connectivity that very few people outside of the research institutions even knew existed. The guiding principle was simple: ensure that computers could talk to each other reliably. Security, that wasn't a priority.
And one of the first things I did when I got to Bell Labs was, this was a room that had about 5 or 6 computers. Again, this is a long time. This is more than 40 years ago when PCs didn't exist. And microcomputers, as they called them, were just toys for hobbyists. So it was a very large room with about 5 or 6 computers. And I designated one of them to be our gateway to the world. There were a lot of reasons for doing that, but one I specifically had in mind was security. This was the only machine exposed to the outside world, not the others. I just went on from there.
But as more institutions joined ARPANET, cracks in this idealistic approach began to show. Unauthorized access and system misconfigurations were already being noticed, but they were mostly seen as technical inconveniences rather than security risks.
It turned out that if you made certain misconfigurations of your computer hooked to this network, you could bring down the whole network. And I said to myself, what would happen if somebody did this deliberately? And that's how I started doing network security in the mid to late 80s.
One of the earliest documented cyber intrusions occurred in the mid-1970s when a high school student successfully gained access to ARPANET using credentials obtained from a leak user manual. Instead of sounding an alarm, the event was largely brushed off as a prank. As security concerns grew, researchers and engineers began experimenting with ways to filter network traffic. In 1988, a researcher named Jeff Mogul at Digital Equipment Corporation, DEC, developed a system called ScreenD, one of the earliest known packet filtering firewalls. This system could inspect network packets and allow or block them based on predefined rules, but it had major limitations.
Jeff Mogul's packet filter was what a lot of people were using. So I talked to Vixie, and he was using Jeff Mogul's packet filter, which was essentially the same thing as a Cisco router filter set. It had TCP connected and a few things like that, but it didn't have any kind of state of the connection. And because I was a network programmer at the time, I started going, that's not right. For one thing, FTP wouldn't work through it. But also, I was worried about IP spoofing attacks. I was worried about bad packet attacks. I talked to Ches about that. And in fact, I suggested that, maybe someone could take a system down by crafting a bunch of packets full of random headers, just throwing random headers.
The early commercial routers, which didn't come out until the late 80s, already had some packet filtering built in. Not quite good enough for firewalls as we would have liked to have built them for arcane technical reasons, understandable for performance reasons, but some of the basics were already there. And I started working a lot with Bill Cheswick. And 1992, we ended up on Amtrak to a conference in Baltimore, and he suggested, let's write a book on internet security. And I don't know what would have happened. We worked out the table of contents. It was originally going to be a collection of papers books. There were a lot of people thinking about internet security in those days because there wasn't a whole lot out there.
So I started to meet all of these people in the security world, and all of these ideas were bumping around in my brain. And somewhere around my Christmas holiday, I decided I was going to experiment and start trying to rough out some code. And I took the idea of Cheswick's circuit relay stuff, which was really Fred Tricky's circuit relay stuff. And I realized that you could write in so the way the circuit relay stuff worked is you would be writing an application. Let's say you wanted telnet. You would take a version of telnet and you would link it against the circuit relay library. So when your version of telnet tried to open a socket to someplace, it would actually connect to the server and say open a socket to someplace, and then it would go into bit copying mode. It was a proxy, except it was embedded in the application. And I realized that you actually didn't have to do that. For all of these different applications, you could spoof the endpoint and force the person to react using a normal version of Telnet, normal version of FTP, normal version of RLogin. So you try to RLog into my firewall, and instead of seeing the prompt on the destination, you would see a prompt saying, "What is your destination?" You enter it, and boop, now you see a prompt on the destination. Same thing with FTP. You FTP to the machine, and then it would ask for your username. And instead of giving your username, you would say user at the destination that you wanted. And then it would ask for password, and then it would just relay the password. And because I was a pretty darn good network programmer at that time, I was able to handle the process of doing like all these weird network handoffs that had to happen in order for the traffic to go through. And so over this Christmas vacation, I wrote, I guess it was 4 proxies. And I came back in and I sat Fred down, and Fred assigned me to explain. We had this old programmer who was from the PDP 5 or whatever, PDP 10 field service guy, Rick Murphy, amazing character, like the original quintessential old school programmer. He wrote Tico. I mean, like in assembler, he wrote editors on, for fun. Um, and so Fred told me, explain it to Rick, because he knew that Rick would just poke holes in all this stuff. And apparently Rick went back to Fred and said, "This is really good stuff. This kid's got it working." And it was pretty cool. And the other thing that I remember popped into my head at that time was, oh yeah, so big point I was about to forget. So part of the reason why Brian Reed was so pissy about all this was because Kevin Mitnick had managed to convince somebody at the Deck Western lab to create an account by sending fake emails. So, so Mitnick got somebody at Deck West to create an account on their firewall for Kevin Mitnick, and so Kevin was going in and out through that, and so that was also an idea in my head. So I started to think about, all right, so the Deck West approach was you have this box that's just got users, and you log in and then you log out the other side. And that was where I came up with the term gateway host and bastion host. It's just like having a virtual host now, right? A virtual machine. Yeah. And what the Bell Labs guys had was a circuit relay where you were still on your machine, but the traffic was going. And so I kept seeing, like, I saw all these common factors, right? And then I had these proxies that I had written, and I realized that what I could do is I could create a box that just had proxies running on it that didn't have any user IDs at all, right? And I remember, like, I had this big aha because of the way that Mitnick had embarrassed the guys at Deck West. I realized that, like, if you could just throw all the users off the machine, you've solved half your problem, right? But the approach that Ches was doing, where people had to modify their software, didn't seem like a great idea. So I took all those things together, and then I had an old Microvax 2 that Rick Murphy and I used for various testing crap. It was just a rack that we'd thrown stuff in and it worked. It was running Ultrix 3.1, something like that. Anyway, not 4 meg machine. I mean, this was a monster. And so I had a tremendous amount of leeway, which was great. And so I just kind of put the thing together exactly the way that I had wanted to, with everything locked down as tight as I could, and then the proxies, and I replaced our existing internet connection with that.
By the late 1980s, firewalls were evolving from academic experiments into essential security tools, but there was still no commercial market for them. Security-conscious organizations like AT&T Bell Labs, Digital Equipment Corporations, and Trusted Information Systems were developing internal solutions, but firewalls had yet to be seen as standalone products worthy of investment.
And I wrote a paper that got accepted by Usenix, and I think it was at Boston, Usenix Boston. I don't remember. Anyway, the paper was Toolkit and Methods for Internet Firewalls, by me and Fred. And that got published, and then I started getting interested in the code. I shared the code with a few people, but I didn't publish it because it wasn't my intellectual property. Then Fred quit and went to Trusted Information Systems. I was real happy with Deck. The water was starting to get into the ship a little bit at that time. And so, oh yeah, I won a pre-sales award for some of this stuff. But one of the other things that happened around then was we had one sales guy who was really aggressive. He was one of those sales guys who'd sell anything. And he sold a copy of Marcus's Firewall to DuPont Research Labs. So suddenly we had a real customer. But that was really funny because, I was driving up to DuPont in my little rented car and stuff, parking next to the Ferrari owned by the guy who'd invented Kevlar. And then I was installing these little deck stations down in the computer room right next to their Cray YMP. Um, and I came up with a 3 system architecture because these processors weren't very fast. I mean, we're dealing with slow machines, right? So what I did is I had one machine that was running filtering, one machine that sat outside and ran the proxies, and one machine that sat inside and ran the email processing. And the fact that it also let us sell a couple more boxes wasn't bad. So the guy from DuPont, I think he paid like 75 grand for this, set up and operating. And then we sold another one to Bill Bonney, sold another one to Exxon Research in New Jersey. And I wound up out at Exxon Research, and because Exxon was getting ready to hook to the internet, and this one guy, Brian Boyle, was terrified of that. And somehow or other, I guess he'd seen my paper at Usenix and talked to the folks at DuPont or something. Somehow it came back, and I said, we can solve that problem for you. Talked to Bill Bonney. Bill Bonney said, well, it's 75 grand. I mean, but. So we were in business, and we started selling these. And I kind of turned it into a package configuration where I could just run a script and it would set the machine up and everything. And then, of course, since we were selling it for 75 grand, Fred pointed out that, there should be documentation for this. So I sat down and I had to write documentation, all that kind of stuff.
At this point in time, word was getting out. The Firewall was a real appliance that could be bought and set up for a fixed price. But little did Marcus know his next customer would be one of the most important connections to the entire internet.
And really, I mean, I was just a pre-sale support coder. I wasn't out there publishing like a guy at Bell Labs would be doing. I was just too busy hauling code and shipping boxes. But so Besh explains that the White House wanted to go online, and they need one of these firewall things. And I mean, I don't know if you've ever had. So we talked about it for a while, and I said, it can absolutely be done. Besh was really cool. So he's sitting there going, which I thought was totally fascinating approach. He's saying, the questions are, can we do it? Can we do it in a way such that the White House cannot possibly be embarrassed? And can it be of value? And I said, well, I connected DuPont's research business, which is probably more important than the White House in terms of the stuff that they deal with. Right? I mean, I connected that. Um, uh, Scott Butler. Scott Butler. Yeah. So anyway, so I said, you could talk to Butler at DuPont. He'll tell you, they're running their entire DuPont corporate is connected to the internet thanks to my software, and they've had absolutely zero problems with it. And so Besh was like, well, that's pretty good. I'll make some phone calls and stuff like that. And y'all go home and we'll do a bunch of things. So this was on a Friday. I had a voicemail from Brian Besh the next morning saying, can you come down here to Falls Church as soon as you can? And I came down and he's like, okay, you're the project team lead for White House Internet Firewall project. Fred is the program manager. Give me a hardware list for what you need, and we're going to make this happen.
Entering the early 1990s, we have a more established security community and the first literature around security and firewall topics. For the first time, people were starting to make a community around cyber, and at the forefront was Steve Bellovin and William Cheswick.
It's a core group of about 5 or 6 people who were the drivers of firewall technology in the mid-90s. Me and Bill, Marcus, a guy named Fred Avolio who worked with Marcus at TI, and a guy named Brent Chapman, who we knew from going to Usenix Security Conference. He was not fond of our book because he thought it was at the wrong level. We were trying to teach concepts. He wanted a how-to guide. And my answer to him was, Brent, great, go for it. Write that book. It's not a competitor book. There's room in the world for both of these books because we're trying to teach the higher level concepts and you're trying to teach the hands-on stuff. And that's great. I was perfectly happy to have that book appear as well.
In 1994, Check Point released their first firewall, called Firewall 1, and it's considered to be the first commercially available stateful firewall. This was also the year that Steve released one of the first books to be published in history about internet security, called Firewalls and Internet Security, Repelling the Wily Hacker.
But that was the point where the internet was just starting to explode. So I think it was a good book, but it also The timing couldn't have been better. It came out just when people were desperate for any sort of guidance on how to protect things. Now, round about the same time, a couple of Israelis invented what's now called the stateful packet filter. And that is the basis for effectively all current firewalls. There are often applications that get involved on the firewall itself, but fundamentally it's a stateful packet filter. Now, ironically, I had invented that a few years earlier, but I concluded that it was lower assurance. I did not think it was nearly as secure because of the complexity involved, so we decided not to pursue it. So it got reinvented by these Israelis in '94. They founded Checkpoint, which became one of the major firewall companies. And again, as I said, it was a good product, but one of the things that I always worry about from a security perspective is assurance. Why do I think this is actually going to be secure? And I eventually persuaded myself that it was secure enough, but it's not as secure as circuit level or application level firewalls, but it was more realistic. It was more secure than an ordinary packet filter and more functional than an ordinary packet filter. And it didn't have the disadvantages to client code that circuit and application level gateways would. So it became the path of the future.
Shlomo Kramer and Gil Schwed, somewhere before when we had just started productizing Gauntlet, the firewall. Fred and I came up with that name, and I didn't really like it. But the big joke Fred and I used we always called it the pig, um, which stood for Packaged Internet Gateway, right? So like, oh, we'll sell the Packaged Internet Gateway. You can't do that. So yeah, we called it Gauntlet. But so Fred was the program manager, I was the technical lead, and these Israeli guys came in and they had a floppy disk with the first version of Firewall 1 on it. And I asked them how it worked and everything like that. And they said, well, we took all of the sort of state management stuff that you did. We just put state tables in it's like a Cisco router, except it's got state tables now. And because we modified the kernel of this, they modified Sun's TCP stack, which was really clever. What they did is they went into kernel memory and they remapped the functions for TCP input, and they put a bag of stuff in front of the input routines and a bag of stuff in the output routines that managed the connections and did permission checking. Well, it wasn't a big deal. I mean, it wasn't a huge amount of code, but it had a comprehensible user interface. It was fast and it was completely transparent. And they wanted to sell it to us because we had just pulled in some money. We were raising venture capital, and all this kind of stuff. And they didn't really know what they wanted to do. So they wanted to sell it to us. And that was really weird because I said we should buy it if we possibly could. And then Fred got really mad at me. And he's like, well, we can't do that because, I mean, isn't your stuff good enough? I was like, my stuff's a firewall. This stuff's a firewall. Their firewalls, I'm not going to say it's better than mine, but it's different in a really good way. I mean, the stuff that because of the fact that everything that I was doing at the proxies was working in a TCP connected state, that meant that packet sequences were tracked, packets were error checked. You couldn't do injection attacks. You couldn't do a lot of that kind of stuff. It just worked that way.
In the mid 1990s, we would see a rapid expansion in the adoption of the firewall in many corporate networks as a necessity for internet security. This is when stateful inspection was a core feature of many firewalls. This enabled firewalls to monitor and track the state of active connections while filtering incoming and outgoing traffic. Unlike traditional packet filtering firewalls, which inspect each packet in isolation. Stateful firewalls maintain a state table or connection table to track the context of network sessions over time. This context-enabled decision-making was a real game changer for the security industry. In 2008, Palo Alto Networks delivered the industry's first next-generation firewall. The next-generation firewall was able to deliver an amazing amount of features that the past decade and a half paved the road for. Next-gen firewalls now have the ability to do full stack analysis, not just the middle and lower layers of the OSI model. These new firewalls now have insights to the application layer for the ultimate and total control of the network and its data in transmission. Then, in 2020, Palo Alto introduced the first machine learning-powered next-generation firewall, designed to enhance real-time threat detection and zero-day attack prevention. Unlike traditional firewalls that rely on known threat signatures, these ML-driven firewalls continuously analyze network traffic patterns to identify new and evolving cyber threats. A key advantage of ML-powered next-gen firewalls is their ability to detect anomalies in network behavior, making them particularly effective in securing IoT devices. By learning from traffic patterns, they can automatically generate and enforce security policies, reducing the time attackers have to exploit vulnerabilities. Additionally, these firewalls streamline security management by recommending automated policy updates based on real-time network telemetry. This reduces manual configuration, minimizes human error, and ensures organizations stay ahead of emerging threats. Overall, ML-powered next-gen firewalls provide a proactive security approach, adapting to new network attack methods while optimizing network defense strategies. Firewalls have come a long way, from simple packet filters to AI-driven self-learning security systems. What started as a reactive measure against emerging cyber threats has now evolved into a proactive defense mechanism that adapts in real time. But as cybersecurity continues to change, one question remains. Is the firewall enough? Or will the next phase of network security push us beyond traditional barriers? A huge thank you to Steve Bellovin and Marcus Ranum for sharing their first-hand experiences and insights. Their work helped shape the digital security landscape we rely on today. If you enjoyed this deep dive into the history of firewalls, be sure to like, subscribe, and hit that notification bell so you don't miss out on the next video. Let us know in the comments, where do you think the future of firewalls is headed?